Hello everyone, this video is on applications of Pythagoras theorem. So we'll take up some important questions from this theorem. Look at the first one. It says there are two poles of height 6 meter and 11 meter. They stand on a plain ground. If the distance between the feet of the poles is 12 meter, find the distance between their tops. So two vertical poles, distance between feet is given. We need to find distance between their tops. The question says there are two poles having height 6 meter and 11 meter and the distance between their feet is given 12 meters. We need to find distance between their tops. So let me mark these poles as AB and CD. So AB and CD has got height 6 and 11. Distance BD, distance between their feet is 12 meters. We need to find the distance between their top. That means we need to find this length AC. We would have construction. First of all, we would draw perpendicular from A to fall on CD and then we would join AC. So we see perpendicular is drawn. Now when perpendicular is constructed, ABDE has become a rectangle. So AB and ED would be equal. So is the case with BD and AE. If this is 12, this side would also be 12. Okay, AE is 12. Total CD, which is 11, AB, ED are equal. So this becomes 6. 11 minus 6. This side becomes 5 meters. Now AEC is a right angle triangle. Let us apply Pythagoras. In triangle AEC, AC square would be equal to AE square plus EC square. AC square that we are looking for, AE is calculated, it is 12. 12 square plus EC, which is 5 square. 144 plus 25 makes it 169. So if AC square is 169, AC would be square root of 169, which is plus minus 13. Negative we know would be rejected as we are talking about length of side. Therefore AC is 13, or distance between their tops, distance between their tops is 13 meters. So very important question. So this is found as 13 meters. The next question is the perpendicular from A on side BC of a triangle ABC intersects BC at D such that DB is thrice of CD. Prove that twice of AB square is equal to twice of AC square plus BC square. Alright, the question is there is a triangle ABC in which perpendicular from A is drawn on BC such that AD falls on BC in such a way that DB is 3 times CD. We need to prove that AB square, twice of AB square is twice of AC square plus BC square. According to the requirement of the question, we need to proceed. We would apply Pythagoras in triangle ADB. So in triangle ADB, AB square is AD square plus BD square. Now listen kids, we don't require AD square in the proof. We don't require BD even. So let's replace. How can we replace this? This replacement would be done by switching to another right angle triangle which is ADC, and AD square, which is actually perpendicular would be written as AC square minus CD square. So let's see, this becomes AB square equals to AC square minus CD square. Okay, this replacement is shown here and the last term BD square comes as such. Next step would be, we need to work on this over here. Replace this BD square. BD is thrice of CD. So this becomes AB square equals to AC square minus CD square plus thrice of CD whole squared. It becomes AB square equals to AC square minus CD square plus 9 CD square, and 9 CD square minus CD square would be what? Would be 8 times CD square. Now look, AB square we need double, AC square we need double. We already have got AB square, AC square. Can we multiply whole equation by 2? It becomes twice of AB square, at least one end is obtained. This becomes twice of AC square. From here even one part is obtained from one end, and this becomes 16 CD square. Now let us see, can the 16 CD square be replaced by BC square? Let us look on this now. The information with us was DB is thrice of CD. Okay, DB is thrice of CD. Can I say that BC is actually sum of CD and DB? Yes, figure says so. And can we say this is CD plus thrice of CD? Information says so. Can we say BC is 4 times CD? Perfect. And can we say square of BC would be square of the other end, which makes it 16 CD square? Great. So BC square is 16 times CD square. So 16 times CD square would be replaced, and here we get our result, which is twice of AB square is twice of AC square plus BC square. So that's how this result is proved. Another important question. In an equilateral triangle ABC, D is a point on side BC such that BD is 1/3 of BC. Prove that 9 times AD square is equal to 7 times AB square. Alright, the next one, the most important question. It says there is equilateral triangle ABC in which D is a point on BC such that BD is 1/3 of BC. And we need to prove that 9 times AD square is equal to 7 times AB square. See, kids, remember one thing, whenever it is equilateral triangle, definitely all the sides must be equal. So first thing is, let us assume, let's take each side of this triangle is marked as A units. That would ease out our task of simplification. And now we are applying Pythagoras, in which, because we need AD square, where is this AD contained? AD would be obtained from right angle triangle AED. So we would say in triangle ADE, AD square is AE square plus DE square. AD square remains as such. AE square. Now AE square can be written as, look at the other end, either we write AC square minus CE square, or we write AB square minus BE square. It's one and the same thing, but look for the easiest way. We have the easy triangle on the other end, so I am replacing AE square by AC square minus CE square, and this DE square comes as such. Now I would be replacing all these in terms of A units. Let's see how would this be done. AC square, AB, AC and BC. It is all A units. Okay, so this would be A square because AC is A units minus CE How would you write CE? CE is actually half of BC. So this becomes A by 2. So this is A by 2 whole square. Now DE. DE will be BE minus BD. It is BE minus BD. What is BE? BE is half of BC. So half of BC is A by 2 minus what is BD? BD is 1/3 of BC. 1/3 of BC means A by 3. When you simplify this after taking out LCM, 6 comes here. It's thrice of A minus twice of A, which makes it A by 6. So DE square would be A by 6 and square it. This is the most important thing. If you are able to understand this, next step is just substituting the values and simplifying. So let us see what the simplification results into. This becomes A square, this becomes A square minus A square by 4, and this becomes A square by 36. Alright, next step would be just take out LCM. This is AD square, this would be 36, this is 36 A square. 36 upon 4, we know when we divide we get 9, and 9 times A square, and plus the last term 36 by 36 would be 1, and this becomes just A square. In the next step, I'm writing the next step here. That implies our next step would be 36 times AD square is 36A square minus 9A square would be 27A square plus A square, which is 28A square. And what is A square? A square is side of this equilateral triangle. So the simplification would become 36 AD square equals to 28 AB square. So this is how the result is proved, almost proved. You further put it in the lowest term, divide both sides divided by 4. You get 9 AD square. This is 9 AD square, and this is 7 times AB square. Perfect. I'm sure this must be clear to everyone.